Alright, we'll be taking a look at operations with radicals in this lesson. Now, when I say a radical, if you have a square root sign, that's also called a radical sign. So we'll be looking to reduce radicals to lowest terms, just like we would with fractions or with rational expressions. And the reason is, in this unit and in this course in general, we always want exact simplified answers. So if we end up getting an answer of root 26, I don't want you to say it's 5.1 blah 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 blah. I want you to reduce that root 26 to lowest terms. So these two properties right here are going to help us. And this is something you need to remember. Now, if you have the square root of AB, and remember that means A times B, we can actually break it up into the square root of A times the square root of B. So what that means, so if I give you, let's say, the square root of 20, 20 can be broken up into 10 times 2. So we could write square root of 10 times the square root of 2. Those two are equivalent. So multiplying radicals, you can just multiply them under one radical sign like that. Or going the other way, you can break them up into the multiplication or the product of two radicals. Also, the division of two radicals is the same thing as having one radical sign and the division of just one. So again, if I have the square root of 20, I could write that as the square root of 40 over 2. That is equivalent because 40 divided by 2 is 20. And that can also be written as square root of 40 over square root of 2. So that may not help us in reducing. Obviously, that's not a simplified answer by any means. But we'll be taking a look at how we can reduce some of these answers on the next page. So what the trick is going to be to simplifying radicals is that we want to break up the radical using that first property. So splitting it up into two separate radicals, but we want one of them to work out to be a perfect square root. So on this page right here, and you can copy these down if you have trouble remembering them, but if I can, for example, break one down into the square root of 16 times the square root of something else, I know that the square root of 16 works out to be 4. Or if I can break it down into 36 times something else, I know the square root of 36 ends up being 6. So using these square roots right here, because they work out very nicely, that will allow us to simplify our radicals. So if I have the square root of 48, or just root 48 we can say, I want to break that down into two separate radicals that would multiply together to give me root 48. But I want to choose from this list right here so that I know I can actually simplify it. Now, looking at this, I could divide it out. Let's say I have root 4, and then I would have to multiply that by root 12 as well. So 4 times 12 is 48, and then I could say, okay, the square root of 4 is 2. But I think I can go a little bit more. Just like with fractions or rational expressions, you want to reduce as much as you can. So actually the largest one from this list that can divide 48 is 16. So root 16 times root 3. I can now simplify this. So root 16 is 4, and then square root of 3 I just write as root 3. So just like we have 4x, 4 times x, what this means is 4 times the square root of 3. That is the reduced version of root 48. It's in lowest terms now. Now, just like with fractions or rational expressions, if you chose to go the root and have root 4 first times root 12, you'd end up with 2 root 12, and it's not incorrect. It's not fully correct though, because you could then fully, or you can further simplify root 12. You can break that down a little bit further. Okay, so you have to keep going. So if you choose the largest one, you're saving yourself a little bit of room. Alright, and the next one, again, I want to check my list down here. It could be divided by 4, but again, I can divide 80. I can use root 16 again, and that would have to be times root 5. So 16 times 5 is 80, so that works out. And that'll leave me with 4 root 5. Now we can also add and subtract these radicals just like we do with polynomials. We can combine like terms. So we can only add and subtract radicals that are alike. So remember, if you have something like 4x plus 5y minus 2x, you can only combine the 4x and the minus 2x because they both have x's. You can't combine them with the y. So same thing with radicals. If they have the same radical, you can combine them by working with the coefficients. Now we do want to simplify the radicals first, just to simplify things in lowest terms, and then we can see if we can add and subtract anything. So if I have 2 root 18, I think I can reduce that a little bit. So I'm going to have a 2 out front here. And then root 18 I could divide up into root 9 times root 2. So 9 times 2 is 18. And then the minus 3 root 2 is out here. Now at this point I know the square root of 9 works out to be 3. And then I still have root 2. Now remember, the coefficient out front means that you're multiplying. So this ends up being 2 times 3 times root 2. So 6 root 2 minus 3 root 2. So at this point I've fully simplified. Now I can see that I can in fact combine these because they have the same radical of root 2. And just think of this as, what is 6x minus 3x? Okay, it's the same sort of idea. So you're just subtracting the coefficients, which will give you 3, and nothing happens to the radical, just like nothing happens to the variable when you're adding, subtracting. So it's just 3 root 2. So we can also multiply or divide radicals, and we do this just like multiplying and dividing something like 2x, 5x, all that. You multiply the coefficients, and then you can multiply the radicals just like we'd multiply the variables. So if I have something like this is just the distributive property. So I have root 6 times root 6. So we've been kind of going in reverse, so breaking down one radical into 2. But if you're multiplying 2 radicals, all you have to do is multiply the 2 numbers underneath one radical sign. So that'll be root 36. Then I have root 6 times plus root 10. So that'll be plus root 60. Now again, I always want to simplify as much as I can. Now we know the square root of 36 is actually 6. So one thing to keep in mind, if you're multiplying 2 roots together that are exactly the same, basically the roots cancel out, and we can talk about that a little bit later. But I also want to reduce the square root of 60 as well. So I think I can reduce that too. I can divide that into root 4 times root 15. That works as well. So that'll be 6 plus 2 root 15. So I'm looking at this. I don't think I can reduce 15 anymore using our perfect square roots. So that's as far as I can go.